All right, let's take a look. So, related rates. Click those closed. Everybody plugged in here. So, a dinghy is pulled toward a dock by a rope from the bow through a ring on the dock, okay? 7 feet above the bow. The rope is hauled in at a rate of 3 feet per second. So the first question is, at what rate is the distance between the dinghy and the dock changing when 25 feet of rope are out? So you guys got to work through this. I will facilitate. I'll write for you up here, but what are you going to do?
We need to write everything we know.
Okay.
Write everything we know.
Okay, and we probably want to assign some variables here. What do you think? Abe?
Was the dinghy moving towards it off the X?
Okay, yeah, so the horizontal distance is x, right?
Changing at 3 feet per second.
Okay, good. So if we call this distance right here x,
X dot
good. Then we know that x dot equals -3. Very good. Okay, what else? We might need another variable. Okay, should I make y a variable? No, how come? Because it's constant. So I don't want to make y a variable. Okay? I want to leave it as a 7. Well, what else do I need? I need the hypotenuse. So let's call that like z or something. Okay? So what do we know about z? Z is, okay, so we don't know that value. Okay? Are you guys right with what you got up there so far? Anybody want to?
Well, z dot would be negative.
Ah, yeah. Anybody see that? Because the rope, which one of those lines corresponds to the rope? Z. Okay, so if rope is being pulled in at 3 feet per second, then it's z dot that's equal to -3. And what else do we know from part A?
X is 25. Oh, wait.
Z is 25, and what are we trying to find? X dot. That's what we're trying to find. There we go. Okay. Okay, how we doing? Does that make sense? Okay. All right, so what do we need next? Yeah. Okay, so what's going to be our parent equation here? This would be Pythagorean theorem, wouldn't it? Do we want to do trig here? No. We'll say it again.
For part B, because we have a theta.
Right, okay, part B, which we haven't seen yet. Part B might be trig stuff, right? But part A, there's no angle stuff involved in part A. So we do not want to mess with any trig stuff because we don't know anything about the angles. Good. So this ends up being just plain old Pythagorean theorem. Good. So our parent equation then is what? X squared plus 7 squared equals z squared, yeah. Okay, now what?
Now we
Good. Implicitly differentiate with respect to time. What do we get from the first term? What do we get from the 7 squared? 0. How come 0? It's constant. Okay, equals. What can we do to simplify? Divide by 2. Okay. So we're trying to solve for x dot. So what is x dot equal to? Okay, good. So x dot equals z dot over x. We know z and we know z dot. We don't know x, but what? We could find it, couldn't we? Right? We could do one of two things. We could either find x, or the alternative is we could just solve for x in terms of z. Right? If I solve for x in terms of z, what do I get? What do I have to do to isolate x? Subtract 49 and then square root. So I would get x equals square root of z squared minus 49. Everybody agree? And my choices are, I could either assign a value to that and put it in my frame value list, or I could just plug that in to my expression right there. And then I get my answer in terms of frame values that I already know. Everybody see that? Okay, take your pick. I think to me, I would rather just plug that in and not have to make another numerical calculation. I'd rather just make one numerical calculation. So we end up with z dot over square root of z squared minus 49. There's x dot. What's the last step? Plug and chug. Okay, so if we plug and chug, what do we get? X dot equals, z was 25, right? Z was negative 3. Okay, so we get 25 times negative 3 over square root. What's 25 squared? 625. Minus 49. So that's equal to negative 75 over square root of 576, which is what? What's the square root of 576? Anybody know? 24. Yep. And so what's that reduced to?
25 over 8.
Yeah. Okay, real quick, what is that just as a decimal? Okay. And what would the units be? Feet per second, yep. Yeah, I guess that's right. Yeah. Okay, so how fast is
Yeah, it's going to get closer to 0 or this.
Yeah, something seems a little goofy here.
Wait, shouldn't it be negative?
It is negative. That's
Isn't that, so what are you questioning?
I'm questioning the value.
Whoa.
I think it it just seemed to me like it should be less than, the absolute value should be less than 3. Well, I'll tell you what, I'm going to look and see. I think I have that one still up. Let's look. No, that's right. That's right. Okay. Okay, and they actually wanted this as an exact answer, an integer or simplified fraction. So what would our answer have been? Yeah, negative 25 feet per second, right? Okay, part B. Okay, so now we already had a bunch of stuff, right? We could write down all our, we've done some work, so we have a bunch of snapshot values. What are they? What do we know? Same stuff as before, right? At this instance. So we had, let's see, we had z equaled 25, right? Z dot was -3. X dot was negative 25, 24 eighths, right? No, 25 eighths. Right, and what are we trying to find? Theta dot, okay? Okay. So again, what would our variables be this time? Z, okay, we could do z and x, yeah, because that's stuff we know without even, this was a calculated one from the first part, right? What if we didn't even have that, let's say? So we could use z in the hypotenuse then, right? Okay, so we know this is z, not the hypotenuse, sorry, the adjacent side is 7. And we still might need to find that other side, possibly, okay? What's our parent function here? Yeah, it'd be cosine, wouldn't it, right? Okay, so we could set up our parent equation would be cosine theta equals what? Okay, I might pick a different trig function. How come? Yeah, because I got a z on the bottom. That's a harder derivative on the right side, isn't it? 7z to the -1. That's going to, think about that derivative. If I write it this way, I'm going to have z dots and z's on the right side of this thing, right? That's not the end of the world. We know those things, right? But what trig function could I pick in order to get the z on the top, which makes the derivative very simple? I could do secant, couldn't I? Yeah. So instead, what if we chose secant theta equals z over 7? Now, what's the derivative of the right side now? Just z dot over 7, right? Okay. All right, so now what do we get if we differentiate? What's the derivative of secant? No. Secant tangent. Yep. So I guess you're kind of asking yourself, I mean, I don't know, maybe differentiating cosine, maybe that would have been better. I don't know, because you just would have had a negative sign then, right? Maybe that's better. I mean, there's kind of 6 of one, half a dozen the other here. You're either going to get a more difficult right side or left side, right? 6 of one, half a dozen the other. Meaning it's... No one's ever said that. No one's ever said that. No, that's kind of... Right. So, Anson gets it. Yeah, yeah. So let's see. I don't know. What do you think? What do you think? If we differentiate secant, we're going to have to evaluate 2 trig functions. If we differentiate the cosine, we're just going to get a z. I don't know. Maybe it's easier to do the first one. Okay. Yeah. Okay, so what if we do that then? If we do the first one, derivative of cosine theta with respect to t is, okay, negative sine theta, theta dot. On the other side, remember, this is just equal to 7z to the -1, right? So we don't need to use quotient rule here. We'll just use power rule. What's that give us? -7z to the -2, which just puts a z squared on the bottom, times z dot. Okay, so then doesn't that just give us -7z dot over z squared? Right? Okay. All right, so what about that sine theta? What are we going to do with that? We have two options. What are they? Okay, we could solve for theta. We could add theta to our list, right? If we add theta to our list, we have a snapshot here, right? We have this triangle. What color can I use? Oh boy, I'm running out of colors. Use brown. So there's my snapshot of the triangle, right? This is theta. That side is 7. What's z? 25. So what's the bottom equal to? We did this math actually already. It'd be square root of 25 squared minus 7 squared, right? What was that? 625 minus 49? It was 576. What was the square root of 576? 24. So if we just solve that triangle, we've got all the sides in that triangle, right? And so we could either write theta as an arctangent, or sorry, an arc. We would have probably done an arc cosine. And that's just a calculator number, right? Okay, so one option would have been then, down here, we'll call this plan A. Plan A would have been just to leave that theta as a calculator number that we plug in, right? So if we solve for, what are we trying to find here, theta dot? Okay, so theta dot, I could multiply each side by -1 to cancel the negatives. Theta dot then, wouldn't it just equal, not negative anymore, just 7 z dot over z squared times what? Sine theta. But we would do sine, what's our theta? Yeah, we just have an arc cosine, right? And we would just plug all that stuff in and get theta dot equals 7 times 25, oh, not 25, it was -3, right? Z dot. Over 25 squared times sine of arc cosine of 7/25, right? Everybody see that? That's just one big calculation that we would plug in, okay? What's plan B? Same stuff, right? We've got the same, when we solve for theta dot, we get 7 z dot over z squared sine theta. But from our reference triangle, what is sine theta equal to? Yeah, right? If that's theta, doesn't that just tell us sine theta equals opposite over hypotenuse? So you could also just, instead of having to take sine of a cosine, we know that the ratio sine theta is just 24/25. So we get 7 times -3 over 25 squared times 24/25. And then we could just conveniently cancel one of those, right? Everybody see that? And what are we going to get on top? What's 24 times 25? 600. How'd you get it so quick?
25 squared is 625.
There you go. Good. So 24 times 25 must be 25 less than that. Good. So you get -21 -21 over 600. What's that reduced to? Negative 7 over 200. So which way is maybe a little better? I think that way is, because you can write your answer pretty easily as an exact answer without having to do some arcane trig magic, right?
Yeah.
I kind of like the reference triangles. You know that about me. I favor the reference triangles. Okay, good? Good? All right. Okay, I'm going to stop that recording. I'll put that one up there.